Hi, today's lesson will be lesson 1.3a. This will be a two-part lesson. Tomorrow's video will be on the second part. Today we're going to be talking about ordering rational numbers. So let's get started. I'll share my screen with you. And there we are. And we'll hit the present button. Okay. And bring down my tools, and I'm going to minimize myself. And let's begin. Okay, so lesson 1.3a is going to be about ordering real numbers. So the standards today you're going to be working on is I can order real numbers. And that's from 8NS2, using rational approximations of irrational numbers to compare the size of irrational numbers, locate them approximately on a number line diagram, and estimate the value of expressions such as pi squared, square roots that are non-perfect. So let's go. Start with a little bit of our, let's start with my math meme here that I put together. What does it say? What happened to the plant in math class? It grew square roots. Ha, okay, hopefully you get that one. And a little fun today. Okay, let's do some review work. So here's our chart about real numbers. I'll look at that again. Remember that real numbers consist of rational numbers and irrational numbers. Rational numbers have several subsets. Within the rational numbers category are integers and whole numbers. And then the irrational numbers do not have a subset. And then there is also the imaginary numbers, but they are outside of real numbers. They are not real, so they're imaginary. So let's begin. Write all the names that apply to this number, square root of 144 over 3. And remember, sometimes you have to do manipulations to figure out what all the names could be. So for instance, square root of 144, what does that equal? It's a number multiplied by itself that will give you 144. And I just happen to know that 144 is a perfect square. So if I multiply 12 times 12, I get 144. And then on the bottom, I have a 3 yet. And now I can say, well, what's 12 divided by 3? Right, it's 4, isn't it? So now I have to classify 4. So I rewrote square root of 144 over 3 into the number 4. So now I got to decide what category 4 belongs in. So is it a whole number? Is 4 a whole number? Absolutely, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, forever. The positive direction is a whole number. So yes, it is a whole number. Is it an integer? Well, all whole numbers are integers. Integers also include the negative whole numbers, right? Okay. So it is an integer. Is it a rational number? Well, if it fits into the whole number category, that is a subset of rational numbers. So yes, it is a rational number. Is it an irrational number? Well, no, right? That doesn't make sense. How could it be both rational and irrational at the same time? It can only be one or the other. So we'll cross that one off. And finally, is it a real number? Yes, because real numbers include rational numbers. So let's clear my drawings. Well, see what happens if I don't clear them. See if it shows up. Yep. So it is a whole number. It is an integer. It is a rational number, and it is a real number. Now I'll clear my drawings. So that should be review for you. Let's move on a little bit. More review. Identify the set of numbers that best describes each situation and explain your answer. The number of tickets sold to a basketball game. What type of number would that best be described as? Would it be described as an irrational number, a number that goes on and on and on and never repeats and never ends? No, that doesn't make sense with basketball tickets, right? How about a rational number? So like a fraction of a ticket. Could that work? No, you don't normally buy a fraction of a ticket. If you did, they wouldn't let you into the game. How about an integer? Well, an integer can include negative numbers. Can you have a negative ticket? No. So this one should be whole numbers, right? Because tickets cannot be negative, and they are only sold in whole, so you can't buy half a ticket. So whole numbers is the best explanation for tickets at a basketball game. Okay, what about the amount of time that has passed since midnight? Could you have a fraction of amount? Of course you could, right? Could you have a negative amount? No, probably not, right? So did you say rational? Actually, the set of real numbers, right? Because time is continuous, so you could have a number that's irrational that actually fits on the continuum of time. So you can't just classify it as a rational number. You have to go one step higher and say it's a real number, right? So it could be rational or irrational. Okay, a little bit more review. Decide if the statement is true or false. All rational numbers are real numbers. Think about your subsets. Rational numbers are definitely a subset of real numbers, so that is a true statement. Real numbers include all rational and all irrational numbers. Next one, no rational numbers are whole numbers. So if you can find an exception to that, if you can find one rational number that's a whole number, then that makes the statement false. And I can think of a whole lot of rational numbers that are whole numbers too, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, etc. So there are quite a few. There is an infinite amount going to the right on the number line. So that is a false statement. Whole numbers are a subset of rational numbers. So some irrational numbers are whole numbers, or some rational numbers are whole numbers. Okay, now it's your turn to do some review questions. I'll see you back in a moment. Hopefully you did well on those review type questions. Looks like I have a few more review here for you today. Lots of hard stuff. Good to review and to review and to review again. Between any two real numbers is another real number, right? So here's a real number, 0.5. Here's another real number, 2. So square root of 5 is also a real number. Remember, real numbers include the imperfect squares. So square root of 5 fits right in there, doesn't it? What is the square root of 5? Anybody know? 2.24 about. So yes. Well, actually, 2.24 would be on the other side of 2, wouldn't it? Yeah. Okay, remember, real numbers include both rational and irrational numbers. Okay, ordering real numbers. Order these numbers from least to greatest. We have square root of 22. This is the new content now. We have pi plus 1, and we have 4½ So the first step is to approximate the square root of 22. So now we've been doing that for a few lessons, so hopefully that's becoming second nature to you a little bit. So let's do that first of all. Seems to be repeating itself. Okay, approximating the square root of 22. Step 1, find two consecutive numbers that when squared will give you an answer with 22 in between both numbers. So we've been trying to find the upper limit and the lower limit, right? So 4 squared equals 16, that's my lower limit. And 5 squared is equal to 25, that is my upper limit. We know that 22 will fall somewhere in between 16 and 25. So the answer to the square root of it will be somewhere between 4 and 5. So square root of 22 is between the perfect squares of 4 and 5. So step 2 then is to ask yourself, is 22 closer to the answer of 4 squared or to the answer of 5 squared? Is 22 closer to 16 or to 25? What did you say? Let's draw a number line. There's 16, there's 25. Square root of 22 is closer to 25 than it is to 16. So we're going to put it there on the number line. And then what's exactly half, or exactly in between, I mean, 4 squared and 5 squared? What's exactly in between 4 and 5? How do we figure that out? Well, we find the middle by adding 4 plus 5. That gives you 9, and then we divided that in half. So we divided by 2. So 9 divided by 2 will give you 4.5, or 4.5. So if you didn't know that off the top of your head, that's half, right in the middle. So 4.5 is right in the middle. It is right here. And then you square it because you want to see what number you get. So you get 20.25 when you square it, 4.5 times 4.5. And then you compare 20.25 to 22. So now, do we have a new lower limit? We do, right? Because the square root of 22 is going to fall in between this 20.25 and this 25. So now we can get rid of 4 squared as our lower limit, and now our 4.5 squared is our lower limit. Oops, clear that drawing. Okay, so here's that chart again, showing us, move this down a little bit, showing us that 4.5 squared is the new lower limit. So now we have to find an even better, or a better estimate for decimal graduation. So using decimal graduation. So we're going to start with our lower limit of 4.5 and square it, 20.25. Then we're going to also do 4.6 and square it, and that'll give us 21.16. 4.7 squared, it's 4.7 times 4.7, that gives us 22.09. 4.8 squared gives us 23.04. And 4.9 squared gives us 24.01. So now we have to find out, where does 22 fall? Where would 22 belong? Well, it's just a little bit before 22.08, right? That's going to be our new upper limit. It's a little past 21.16. So it's going to fall between those two numbers. So actually, there we go. Square root of 22 is going to be between 4.6 and 4.7, right? So now our step 4 is to find an even better estimate. We're going to find the exact middle. So let's draw on our number line here. We have 4.6 squared, our new lower limit, and 4.7 squared, our new upper limit. And we are going to find the exact center. How did I get 4.65? Well, I added 4.6 and 4.7. And by the way, this is the same way that you would get an average for a set of data. You would add them up and divide by the number of numbers. In our case, we have 2 numbers, so we're going to divide by 2. 7 plus 6 is 13. Carry the 1, put our decimal here. 8, 9, right? 9.3, and then we're going to divide 9.3 by 2. If I was to do that, I would get 4.65. And then I would square 4.65, and that would give me 21.62. So square root of 22 is between 4.65 and 4.7. So we now have a new lower limit right here, because 22 is going to fall between 21.62 and 22.09. So that's an even better estimate. So there's square root of 22 fitting in there somewhere. Step 5 is to choose our final approximation. Now remember, these are approximations, so on a test, you can be close and still get it correct and not have the same answer as your neighbor, because they're estimates. And as long as you're in the ballpark, you will get the answer correct. So we are going to choose 4.69. So if I were to multiply 4.69 times 4.69, I would get, let's see, 4.69 and square it. I get 21.99. So square root of 22 is 21. is close to that. 21.99 is very, very close. So 4.69 is very, very close to the square root of 22. Okay, so step one, we approximated the square root of 22, and we said that was 4.69. Step two now is to approximate pi plus 1. This one's a little easier. We know what pi is approximately, what? 3.14 plus 1, right? So it would be 3.14 plus 1 more. Don't forget it's 1. You got to put the 1 under the whole number 3, right? Put some zeros after it. Add that up, we get 4.14. So that's approximately what it is. If you like to work with fractions, you could use 22/7 plus 1 because that also is pi. So let's clear my drawing. So 3.14 plus 1 is equal to 4.14. Okay, step number 3 is to approximate 4.5. So since we're using decimals for square root of 22 and for pi plus 1, let's change 4.5 into a decimal. How do I do that? Well, we take whole number times the bottom plus the top, right? So that's 9/2, and you might just know what 4.5 is anyways without having to do all this, but I want to show you where it comes from. So now you take the 9 in the inside, top number on the inside, numerator on the inside, and denominator on the outside. So 2 goes into 9 4 times. 2 times 4 is 8. 9 minus 8. Okay, 9 minus 8 is 1. I'm going to put a decimal and a 0. Bring down my 0. I'm going to run out of space here, but we don't need much more space. So 2 goes into 10 5 times. Don't forget my decimal point up here. So 4.5 is really 4.5. And you probably knew that off the top of your head, but if not, that's how we got it. Let's clear my drawings. So 4.5. So we have, now we are ready to order our numbers. We have them in the right order to compare them. 4.69, 4.14, and 4.5. And I won't lie to you, these homework problems do take some time. I'm not giving you a lot of them because they do take a little bit of extra effort. But bear with me, 8th grade math, you will get through it and you will do awesome. So, all right, so we can now compare those 3 numbers. So we're going to plot our numbers on a number line. Here we go. Order these numbers from least to greatest. There they are. There's their decimal equivalents from the last page. And now we're going to put them on the number line. There's our number line. And notice how I'm making a number line that starts at 4 and ends at 5. And then I have tenths in between. 4.1, 4 and 1/10, 4 and 2/10, 4 and 3/10, 4 and 4/10, 4 and 5/10, etc., all the way up to 5. So I can plot these in a better way. So there's 4.69. It's very close to 4.7, but right before it. So our square root of 22 is going to be there on the number line. Our 4.14 is a little bit past 4.1. So that's going to be pi plus 1, right? That's going to be right there. And then our 4.5 is exactly on 4.5. So now we know which numbers go from least to greatest. Remember, the numbers go smallest at the left. Let me get my arrow here. The numbers go, they get bigger the farther right you go. The farther right you go, the bigger they are. Farther left you go, the smaller they are. So let us order these. There's our number line again with our numbers plotted from the previous slide. And let's order them. And be careful, make sure you know if it's saying least to greatest or greatest to least. A lot of people get tricked on those. Make sure you look. So step 5 is list our numbers from least to greatest. And you're going to list them in the original number, not in the decimal form. So the first one is going to be 4.14 or pi plus 1. That is furthest left. Then they start getting bigger. 4.5 or 4.5, that is the second biggest, and then the greatest number is square root of 22 or 4.69. So there you have it. Our numbers are in order from least to greatest. We have just ordered real numbers. Least, greatest. And they go from the least to the greatest to the right. Okay, ordering real numbers. Let's try some more. Order these numbers from least to greatest. Again, it's saying least to greatest, but be careful. It could easily say on a test, greatest to least. Okay, here's our numbers. We have pi squared, we have 10, and we have square root of 75. So we have to change them into decimal format. So first we're going to approximate pi squared, right? That shouldn't be too difficult, right? What's pi? That's approximately 3.14. So we would square it. So we would have 3.14 times 3.14. Or we could do 22 sevenths times 22 sevenths if you would rather do it in a fraction form. So 4 times 4 is 16. Carry the 1. 4 times 1 is 4 plus 1 is 5. And then 4 times 3 is 12. Second row, we have 1 times 4. Make sure you put it under the 1. We have 1 times 1, and we have 1 times 3. And on the third row, we have 3 times 4. Make sure you start it under the 3, which is going to be this one. This one's kind of a little bit off. 12. Carry the 1. 3 times 1 is 3 plus 1 is 4. And 3 times 3 is 9. I just want to make sure that I did that correctly. So my 6 goes under here, and my 4 starts under here, and then my 2. Yep, okay. So 6, 9, 5, 8, and 9. And then where's my decimal going to go? Well, we have 1, 2, 3, 4 numbers after the decimal. So we start at the end and we count 4. 1, 2, 3, 4. So it's approximately 9.8596. So that is what pi squared is, 9.8596. And there we're going to round it to 9.86. So there it is in decimal form. And then 10, we don't have to do anything to, right? Because it's just 10. We can't approximate 10. It's already exactly 10. So that's an easy one. And then again, step 3 is to approximate the square root of 75. So let's do that. Approximating the square root of 75. Step 1, we're going to find 2 consecutive numbers, 2 next to each other numbers that when squared will give you the answer with 75 in between both numbers. So if I do 8 squared, I get 64. That's my lower limit. If I do 9 squared, I get 81. That's my upper limit. And square root of 75 is going to be between the perfect squares of 8 and 9. Step 2 is to ask yourself, is 75 closer to the answer of 8 squared or to the answer of 9 squared? Where is 75 closer to? Let's put it on the number line. There's 8 squared, there's 9 squared. 75 is going to be closer to 81, so it's going to be there. So now we got to find that middle number here to get our new lower limit. So we're going to add 8 plus 9 and divide by 2. So 8 plus 9 is 17 divided by 2 is 8.5. So 75 is closer to 81 than to 64, and our 8.5 goes right in the middle. We're going to square 8.5, so 8.5 times 8.5 is going to give us 72.25. So now we have a new lower limit. This is going to be our new lower limit because 75 is going to be between this number now and between this number now. So let's show that on the next slide. find a better estimate using decimal graduation. So now we're going to start with 8.5 and square it because that's our new lower limit. And then we're going to do 8.6 squared, 8.7 squared, 8.8 squared, 8.9 squared. And we're going to decide where 75 falls. Can you see on the computer there, where does 75 fall? Exactly, right between 8.6 and 8.7. So that's our new lower and upper limit. So we're going to find an even better estimate. We're going to find the exact middle of 8.6 and 8.7. And the number in parentheses is the number squared, so we can keep using our 75 and see where that fits. So how did I get the middle number of 8.65? I added 8.6 plus 8.7 and divided by 2, and I got 8.65. And then I squared it to get 74.82. So that will become our new lower limit. Square root of 75 is going to fall in between these numbers, 8.65 and 8.7. So our computer should show us that here. I've designed it to do that. There's square root of 22. It's between, oh, I didn't change the number. It should say between 8, oops, not that one, between 8.65 and 8.7. Typo there, but it should be 8, okay? 8.65 and 8.7. So then, choose your final approximation. What is our final approximation? 8.66 is the final approximation. If I was to multiply 8.66 by itself, I get 74.99. That is extremely close to 75, right? So that's a very good approximation. We can never be exact, right? We can never get exactly 75 when we do this. So 75, or square root of 75, is close to 8.66. Okay, now we have all three numbers in decimal form. Remember, we had pi squared, 10, and square root of 75. We approximated pi squared to be 9.86. 10 just stays 10. And square root of 75 we decided was 8.66. Now we're ready to put them on the number line and compare them and order them from least to greatest. So let's plot them on the number line. That's our next step. Put them back up there for us to look at. There's decimal equivalents. Decimal equivalent is the number below. Except for 10, that doesn't have a decimal equivalent, it's just 10. Bring our number line down. There it is. And notice how I did graduations of, and move that black bar, 8.2, 8.4, 8.6, 8.89, 9.2, 9.4. So notice how I did by 0.2 this time. You can adjust your number line to work for you. So we're going to plot 9.86. That's going to, we're going to plot square root of 75, sorry, 8.66. That's going to go right here, right between 8.6, get that black bar out of the way there, 8.6 and 8.8. And then we're going to put 9.86 over there between 9.8 and 10. And then we're going to put 10 on 10. So now we know which number is the smallest, the most left one, and which one is the biggest, the most right one. So let's put them in order. Order the numbers, so list them. Least is first, so square root of 75. Then pi squared, and then 10. There they are from least to greatest. Least to greatest. Going from left to right. Okay, you get to practice this. I will see you in a moment. Give it a try. Hopefully you did well, and let's continue. So we're going to focus a little bit on some higher order thinking. Pi is approximately, there's the number, 3.141592653588979, etc. Never repeats, never has a pattern, never ends. There are several approximations used for pi. So some of them include 3.14 and another one is 22/7 or 22/7. Both of those are approximations for pi. So we're going to plot pi and the two approximations for pi on a number line. So we're going to use the pi number up here for pi, this one here. And then our two approximations are this one and this one. We're going to plot those three on a number line. So there's our number line, and notice how I adjusted my number line to fit what I needed. 3.14 is the lowest number I need. Get that black box to go away. And then at the other end, 3.145 is as far as I need to go to the right. And then I have, in between, I have it going up by thousands. 3.141, 3.142, 3.143, 3.144, and then 3.145. All three of those numbers will fit. So we're going to put pi there. That's 3.141592653588979. It's going to be a little bit before 3.142. And then we're going to put 3.14 over there on the left. And then 22/7, if I was to divide that out, when I divide 22 by 7, I'll do that with my calculator just real quick here. 22 divided by 7, 3.142857. So it's right before the 3.143. So what was the question? There are several approximations. Okay, note that there was just plotting different things for pi. Which is a better estimate for pi? So which one is closer to the actual pi? So is it going to be 3.14 or 22/7? Let's bring our number line back down, put our numbers back in there. There they are again. Which one's closer to the actual pi, that big long number? Can you tell from the diagram? Right, 22/7. 22/7 is closer to pi. So it's actually a better approximation. Okay, your turn to give a more challenging question a try, and then we will be ready to end the video, I believe. Let's see. Yep, okay, so I'm putting homework on Google Classroom now instead of on the video because sometimes I change my mind, and if it's on an asynchronous video, it is too late to change the assignment once it's been recorded. So this way I have the opportunity, I'll put myself back on there. This way I have the opportunity to change the assignments as I see fit to help the class. So look for your assignment on Google Classroom, and I will see you in the next lesson. Have a good one. Bye.